this video lesson on the LTV 1000. It's a portable and lightweight transport ventilator which is now in its second decade of operation with CCAS. The LTV is electrically driven, which means it is also O2 efficient. It can operate in both high and low pressure O2 sources and has 9 modes of ventilation in total. During this lesson, we'll learn how to operate all aspects of the LTV, including a pre-user check and some troubleshooting. Let's start by orientating ourselves to the component parts and the consumables that will be used during this lesson. Starting off with the LTV itself, you can see here in its blue carry case, the LTV transformer, the high pressure O2 hose, which we'll take a closer look at during the pre-user check, an external power source, in this case a 12 volt 12 amp hour battery which we use during CCAS missions, a small CD oxygen cylinder, and a patient breathing circuit with an HME attached. Although there is a bracket which attaches the LTV to the NATO stretcher securely, it's important to remember that it's a carry case which makes the LTV airworthy as per the RTS. We're now going to move on to the pre-user check. We need to confirm the following: that the LTV is unplugged from the mains. We then want to remove the LTV from its transport carry case. We need to confirm in the front pouch of the carry bag there is a test lung and a screen protector. Once we're happy with this, we can place these back into the bag. We then need to inspect the carry bag itself, checking for any dirt or any obvious signs of damage. We want to pay particular attention to the carry handle along with the shoulder strap and ensure that these remain intact. We then need to pay particular attention to a number of D-rings, 5 in total, on the back, and ensuring that the material also remains intact. So once we're happy with that, we can pop the carry bag to the side and focus on the LTV. The next component we're going to inspect is the transformer. We're going to be checking this for any dirt, dust and damage. We want to pay particular attention to the wires and the joints where they meet the transformer. We all need to ensure that there's no exposed cabling. We also need to check the TMW asset number against 373 documentation and that of the LTV and ensure that the MDSS sticker has an in-date service. We're then going to look at the LTV itself. We're going to give this a thorough look over, inspecting it for any obvious signs of dirt, dust or damage. Looking at the right side of the LTV, we can see a few of the sensor ports here, which we'll go into in more detail, the patient circuit port and then the speaker. On the left side of the device we can see the air and the fan filters. These filters, both of them have to be replaced every 30 days. The air filter is notoriously difficult to remove the plastic casing, so please be careful with this. We then need to inspect the power connection port, ensuring that there is no exposed wire. The next thing we're going to inspect is the O2 hose. We need to ensure that the cover is intact with the lanyards. We can then inspect the connection port more closely, ensure there's no damage and that it has a red rubber seal which is present. Once we're happy with that, we can reattach the O2 cover, and that's the physical checks of the machine itself complete. The next component we're going to inspect is the high pressure O2 hose. This should come in its own carry bag, which isn't present here. We want to pay particular attention to the regulator. We also need to note the expiry date. This is usually displayed on a rubber band on the hose itself, in this case the orange one. The hose expires after 4 years. The most important thing about the O2 hose is to ensure that the integrity of the black O-ring, which you may be able to see here, is actually intact. In order to conduct the 373 functional checks, we need to assemble all its component parts. The O2 hose screws on here, and we must ensure that we only secure it hand tight. Once we're happy with that, we need to attach the regulator end, the Schrader valve, to the oxygen cylinder. We then need to connect up the test patient circuit, the elephant tubing secures to the bottom. Then we have 3 sensors which have to attach just into the middle of the ventilator. Each sensor connection can only attach to its opposite part, so the exhalation valve to the bottom. the yellow low pressure sensor to the middle and the white high pressure sensor to the top, and we just need to ensure that these are secured firmly. The final thing we need to do is connect the LTV up to its mains power supply. Now that the component parts have been checked and reassembled, we want to check the function of the device. To switch the LTV on in test mode, press and hold the select button and press the on off button. Once remove patient appears on the display window, you can remove your finger from the select button. To silence this, press the silence alarm. Now that the device is in test mode, the first menu that we see is vent check. We want to enter this using the select button. Press the select to enter the alarm, and this tests the audible alarm. Press the select button to move on to the next item to check, which is display. Pressing the select, you can see that every LED on the ventilator lights up, excluding the vent in-op, which should only light up when the device has been switched off whilst the ventilator is operating. Press the select button to move to the next menu. As the control, here we're going to check each of the device buttons to ensure that they relate on screen to what they say above and below. Starting with the select button, we move through each of the buttons, ensuring what is displayed is accurate to its description. Remember to include the on-off button to test for this. Then we can press the select to test for the pressure and the leak in the system. We must occlude the system, the circuit, using our thumb to occlude. We can then press select for the leak test to run. Here we're looking for a number greater than 45 and less than 1 litre per minute for the leak. When the ventilator displays leak pass, we can move on. Pressing the select button, we then move to the next menu. Once the device has passed its leak test, we switch the device off, press and hold the on-off button. The audible alarm will sound, the vent in-op alarm will illuminate. Allow the alarm to signal for 15 seconds and press silence. Switch the device back on in test mode, pressing and holding select, while simultaneously pressing the on-off button. Release and select when remove patient appears. The next menu we want to check is the alarm op. Press the select, and we're going to scroll through each of these menus to ensure that the correct parameters are displayed. The volume ranges between 65 and 85 decibels. We keep it at 85 decibels. Press the select, and on to the next menu. Current apnea settings should be 20 seconds. The device has a range between 10 and 60 seconds. High pressure delay can be set to no delay, 1 breath or 2 breaths. We currently set to no delay. Low peak pressure alarm, we have set for all breaths. High frequency, relating to the frequency respiratory rate, is set dependent upon the patient's needs. This can also be set as a time, between 0 and 60 seconds. IP would be selected based upon patient need. Patient assist can be selected to normal or pulse. For CCAST, we have selected a normal. We then exit the alarm op menu and proceed to the vent op menu. Again, scrolling through each of the menus to ensure that the correct parameters are set. Rise time is set to profile 4. This has a range of 1 to 9. Flow term set to 25% to peak flow. It has a range between 10 and 40%. Time term, this is a range between 0.3 and 3 seconds. We have it set at 1.5 seconds. PC flow term, we have selected for off, and it switches between on and off. Leak compensation is on. The LTV will compensate for up to 6 litres per minute. NPPV mode, so non-invasive positive pressure mode. This is set to off, and we don't use this for CCAST. O2 flush set to 3 minutes. Control unlock is the key that we use to lock and unlock the keypad. We have it set to easy. It can also be set to hard, which just means that you have to press and hold the control unlock for 3 seconds in order to unlock the keys. The next few menu items we don't check, but of course the language should be appropriate. The next one that we do check is the date. We want to ensure it's in date and it follows the format of day, month, year. Same for time. We want to ensure that the time is correct in Zulu. And this is just where we confirm the format for our date. The PIP LED we have switched on. And that's us completed the vent op menu system. Next, we want to check the function of the ventilator. So we need to attach up the test lung to simulate attached to a patient, and then we'll run through some real-time data to ensure that the ventilator is operating accordingly. So for this we need the test lung, and we also need the 12 amp hour battery, which I've got beside me now, so that we can test the device operating on an external power source. Connect the test lung up to the end of the patient circuit. And then we want to press the control unlock, which takes us into a ventilation mode. So from here we just want to select some nominal values. We put the system into pressure, SIMV, respiratory rate of 12, pressure control of 15, respiratory time of 1.6, pressure support of 15, leave the oxygen at 21%, and the sensitivity to 3 liters per minute. So from here we want to go into see real-time data transducer, so we press and hold the select button. We keep holding this down until we come back into our extended menu options. If we scroll through, we're looking for the real-time transducer data. Press select to enter this menu. There's a few things that we're looking out for here. First thing we want to check is the O2 PSI. So if we scroll through, See, we're now on the O2 and this is the PSI. We want to ensure that this number remains above between 40 and 80. So to test this, we'll increase the oxygen to approximately 40%. This allows us to put a bit more pressure on the hose. Once we've got this running at a higher percentage of oxygen, we can give a bit of a wiggle test just to ensure that the number doesn't fall below 40. Once we're happy with the pressure in the system, we can put the oxygen back down to 21%. We now want to check the internal battery. So if we scroll to the right, you can see the battery voltage. This is the battery voltage for the mains adapter. So if we disconnect, it should say power has been lost. We can silence and reset this. What we also notice on the battery level, we're now switched to internal battery. So this is indicating the level of power that we have remaining in this battery. We'll put on the screen the quantities against the colour of the LED for this. And all we want to check that whilst this device has been on charge, that it remains above 12 volts. We now want to test an external power source, so we'll test our 12 amp hour battery. So if we select the external voltage and then connect up the 12 amp hour battery. Connect the external battery up in a similar way to connecting up the mains adapter. And again, we want to confirm that the voltage for this battery is above 12 as long as the battery has been fully charged. Once we've done this, that's the checks complete. We can switch the device off. Press and hold the power button. Again, looking at the vent and op LED is illuminated and the audible vent and op alarm sounds. We can silence this. Something that we've also not discussed for this ventilator is that it has no internal O2 analyzer. So to combat that, and in order for us to be able to analyse the concentration of oxygen that we're actually set and confirm that it's been delivered, we have to use an oxygen analyzer and connect it up to the LTV. We use the Teledyne O2 analyzer, which there is a separate video on this, so this won't go into that on how to operate it, but what we will do is discuss where it goes in relation to the ventilator. So if we disconnect the patient circuit, on your O2 analyzer there should be a T-piece, connects up where the patient circuit goes, and then we reconnect the patient circuit here. The O2 analyzer then just needs to be switched on, and of course this would be calibrated, but like I said, this won't be covered in this particular video. So we'll switch the ventilator on in ventilation mode, so just press the on off button. You see all the LEDs illuminate except for the vent and op. Now the ventilator defaults back to its previous settings depending upon which was already set. For the purpose of this video, we'll keep the high pressure limit above 100, and if we have erroneous alarms, we'll just change these so that the ventilator doesn't alarm. But of course these would be set appropriately for your patient. We can see here the display screen scrolls through all the parameters. So we can see on the control buttons that some of the LEDs are lit brightly and some are dimmed. The reason why the tidal volume is dimly lit is because this mode is a pressure mode. The tidal volume will be achieved by selecting the pressures. So the first thing we'll cover is the select button. If we press select, we can speed up the scroll if we want to see a specific parameter on screen. If we press and hold the select button, we'll return to the extended menu where we can check things like alarm op, vent op, and all the things that we've checked on our pre-user check. We can also set and our alarm up, our apnea settings, high frequency and our high PEEP should be required for our patients. To come from this, we want to go to exit and then continue to the exit again. And again, we'll now scroll through. If we double press on the select button, this returns to the scroll. To use the controls, we use breath rate for example. If we press it, we realise that the rest of the controls become dimmed to tell us that we are now on this. We have a few seconds before this will cancel, so again, press the breath rate, use the jog dial to go up and down and select the appropriate setting. Press the button again to confirm, and this goes for the remainder of the buttons. So just another example: to increase the oxygen, press the oxygen and switch the oxygen up, press to confirm. So taking a closer look at some of the control options that we have, we've already covered breath rate, tidal volumes, which we could select if we're in a volume mode, which we'll come to in a minute. Pressure control, this is the amount of pressure we are generating to give the patient, so this is controlled rather than what we're given for a support breath. We can change the inspiratory time, pressure support, fraction of oxygen that's been given, and the sensitivity. We've already covered the on-off button. Here we have the volume or pressure selection, so if we want to change between volume and pressure, we press, you can see we're on pressure. If we press once, volume flashes, press again to confirm, and we're now in volume mode. We also notice that the tidal volumes become brightly lit and the pressure control becomes dim lit. So if we wanted to change the tidal volume now, we can press, use our jog dial and press to select. Tidal volumes for this mannequin won't be accurate because this mannequin isn't set up to take ventilation. Just like changing between volume and pressure, we can also do this between the assist control and the SIMV mode. So if we press it once, the LED flashes and press to confirm. This just now says that we're in volume and assist control mode. At the beginning we mentioned that this ventilator has 9 modes. So we've got volume control, pressure control, volume assist, pressure assist, then we have volume SIMV, pressure SIMV, there's also CPAP and CPAP pressure support, and the final mode is non-invasive ventilation, which we won't cover at all during this video as we don't use it for CCAST. We then have the inspiratory expiratory hold. Now, in order to give an inspiratory hold, we must be on a volume mode. So if I press this, we can see up here that it's selected inspiratory hold. Now press and hold, and we wait for the C static to appear on the screen, and that will determine that we've completed the full inspiratory hold. To complete an inspiratory hold, we can be in volume or pressure, so we can press the inspiratory hold, press it again, now inspiratory hold appears, and press and hold. And again, we'll know that this is complete when auto PEEP appears on the screen. To show that when we're in pressure mode, that the only function available is an expiratory hold. So if we press, the first thing that appears is expiratory hold. If we press again, nothing, so it switches itself off. So we can only conduct an expiratory hold when we're in a pressure mode. To deliver a manual breath, we press, and when the LED illuminates, breath is administered. So we can see here, also with the real-time barograph, if we press that on expiration, that it also takes a breath. We'll cover the low pressure O2 separately, but this, if we have a failure on our high pressure O2 hose, we can deliver oxygen through the low pressure O2 source. The control lock button just locks all of our buttons, so if we have this on and we try to change, we notice that it says that it's locked. To unlock this, we press the control unlock button, and because we've already preset this to control unlock set to easy, that allows us to do that with one click of the button. Alternatively, if it was on the hard setting, we would have to press and hold for 3 seconds. Over on the far side we have our external alarms, as we call them: high pressure limit, low pressure limit and low minute volume. These are set in identical ways to the functions over here. Press the limit we wish to set using the jog dial up and down, and then press to select. Now, one of the slightly more unusual aspects of the LTV is that the PEEP is delivered via an external PEEP valve. So in order to set the PEEP, it must be done here. Now, we're on PEEP at the moment, but as the display scrolls through, we want to be able to see the PEEP that we're delivering. So if we press the select button until PEEP appears, this should keep this on this screen whilst we change. To change the PEEP valve, we want to press the yellow button in, and we turn the dial simultaneously, and we can see that we've now went up to 9 centimeters of water of PEEP. So if we try and put this down to 5, we press the yellow button and we turn it slowly. Because of the way that the PEEP is set on this via an external PEEP valve, we have to take into consideration that when we transfer from a regular hospital ventilator, most of these ventilators have internal PEEP. So in order to do the transfer appropriately, we must add the PEEP that's set on the hospital ventilator to the pressure that's also set. So we set above PEEP. An example of this: if the patient was on 10 of pressure control and 5 of PEEP in the hospital, we would then set our pressure control to 15 and also set our PEEP to 5 via the PEEP valve. When the ventilator alarms, we have both an audio alarm as well as a visual display on the display window. So if we can simulate this by disconnecting, we can see a disconnection or a sensory alarm is now flashing on screen. To rectify, we are obviously going to reattach. The audible alarm cancels once it detects that the issue has been fixed, but we still have the flashing display screen. To clear this, we press the silence and reset. Additional alarms that the ventilator will sound will be your high pressure, your low pressure and your low minute volume. As we can see here, we're currently in pressure assist control. Now, if the patient was sufficiently awake enough, they would be able to trigger breaths because we've got the sensitivity set to 3 litres per minute. If we switch this off by rotating the dial to the dash, then the patient will only receive mandatory breaths at a rate of 14 per minute with a pressure control of 15 with the PEEP set at 5 or 6. If we turn this back on, we can change between assist control to SIMV CPAP, to go into full CPAP mode without any pressure support. We switch our pressures off, dash dash. The respiratory rate would be set to off, and now the patient will only the patient triggers the ventilator. In this scenario, our mannequin won't initiate any breaths, so after 20 seconds we should see our apnea alarm. 20 seconds have now passed. The ventilator defaults into apnea mode. The default breath rate is 12 breaths per minute, and the default mode will be the previous mode that we have set on the ventilator. In our case, it would have been pressure control SIMV. So we can clear this alarm in two ways. If the patient was to take 2 consecutive breaths, or using the silence reset button. And this now gives another 20 seconds before the apnea alarm would kick in again. We'll switch the breath rate back on so that this doesn't happen. As a reminder, as we can see here, we have the 3 external alarms, but to set the PEEP and the respiratory rate alarms, we have to press and hold the select button so that we can enter the extended menu. And once that appears, we now select for the alarm op, and we scroll round until we see high frequency. If we select this now, we can select frequency and change this accordingly. We then scroll to the high PEEP, press select, and we can see it's currently set at 10, but we can change this by using the jog dial. Once we're finished with this, we press exit and again to turn to the ventilation mode. Should the device fail under high pressure, then it can also be operated on the low pressure system. In order to be able to do this, we must have the adapter and some green oxygen tubing. You can see now we've simulated a low pressure O2 alarm. So what we can do is we can silence the audible alarm. Now continue to flash here. At this point in time, we would transfer our patient over to something like the ambibag or the water circuit. We then need to disconnect the high pressure hose, so we'll do that from the O2 cylinder first. And then we'll disconnect it from the ventilator. Once this has been done, we can press and hold the low O2 source, and we can now see that the LED is illuminated. We can now clear the visual alarm because we're now delivering through low O2. Currently, the device would be delivering 21% room air. To be able to increase that, we connect our adapter where the high pressure O2 hose would sit. Attach the green tubing to the adapter, and then the other end connects to our oxygen cylinder. To deliver an increased oxygen flow more than room air, we change the cylinder to the appropriate litres per minute. With the O2 analyzer attached, you can see that setting the cylinder to 2 litres per minute delivers approximately 40% of oxygen. To increase this, we just simply increase the flow rate of the O2 cylinder. So that brings this lesson to a close. Thanks very much for engaging. I appreciate that this is a lengthy video, but you understand that ventilators are a complex piece of equipment. This lesson isn't intended to replace formalised face-to-face training where you'll receive much more practical demonstrations of using this ventilator. We look forward to seeing you on your course. Thank you and goodbye.